Okay, for this video, I'm going to work through all of your assignment problems for section 11.4. So if you followed directions yesterday, you watched the video and you started the assignment. And today I'm just going to work through all of the problems. So if you have some issues with any of the problems that you did yesterday, then you can jump around in this video to find the work for any particular problem. All right, obviously I'll just be going in order 1 through 8, number 10, number 13, I'll just be going in order. Okay, so feel free to jump around so that once you're done with this video, you should have a complete assignment for section 11.4. Okay, so number 1 asks for the population density, so just exactly what the video was talking about yesterday. So population density. Again, from yesterday, it's simply going to be the number, in this case, number of people divided by area. And this number 1 example uses the state of Kansas. In the problem, it tells us that there's approximately 2,910,000 people in the state of Kansas. And then they give us a picture of the state of Kansas with approximate measures. The idea is we don't worry about this northeast corner. Kansas, for the most part, is a rectangle, so the area of that rectangle is going to be approximately its length multiplied by its width. So in this case, 400 times 210. So the area of Kansas is approximately 84,000 square miles. So that means there's 2,910,000 people spread out across an area of 84,000 square miles. So when we do the calculation, 2,910,000, there we go, divided by 84,000 square miles, we get a population density of approximately 34.6 people per square mile. Okay? All right. Number 2 gives us some animal information about Yellowstone. It says Yellowstone has an area of about 2.22 million acres, and then they show the approximate populations for some of the animals, and it asks us to find a population density for each of these 4 animals. Okay, so what we'll be looking for is population density for grizzly bears. So just kind of abbreviate that. Population density for elk. Sorry, you gotta learn to spell. For elk in Yellowstone. Population density for mule deer. And finally, the population density for bighorn sheep. Okay, just abbreviating each one of those. So population density, again, is going to be number divided by area. So grizzly bears, there's approximately 712. There's approximately 20,000 elk, 1,900 mule deer, and 345 bighorn sheep. The area given to us in the problem is 2.22 million acres. So 2,200,000 acres. So that'll be the area that we use as the divisor for each of our density problems. All right, so it just simply becomes a calculator problem for each one. So grizzlies, there's going to be 0.00032 grizzly bears per acre. Elk, that will be approximately 0.009 elk per acre. Let's see, what do I have next? Mule deer would be 1,900 divided by 2.2 million. And so that's approximately 0.00086. Mule deer per acre. And finally, bighorn sheep, 345 divided by 2.2 million acres. And that one would then be 0.00016. bighorn sheep per acre. Okay, like always, feel free to pause the video if I'm going too fast for anyone. Or of course, like I said before, jump around to hit the problems that you need to. Number 3 just simply says about 210,000 people live in a circular region with a 12-mile radius. So this time, instead of rectangular, we have a circular region. So this might be something like a city centered on a point, right? So we're looking within a 12-mile region of a city, okay? And they're looking for, once again, population density. So that's going to be the number of people divided by area. So number of people divided by area. And in the problem, it says 210,000 people live in this circular region. And the area, because it's a circle, we have to find using our formula for the area of a circle, which is pi times the radius squared. So the radius of this circular region is 12, so it'll be pi times 12 squared, which gets us an area of approximately 452.4. So this would be the number of people, and this would be measured in square miles. So when we do the division, 210,000 divided by 452.4, yeah. And we get approximately 464 people, 464, let's go 0.2 people per square mile. Okay, number 4, about 650,000 people live in a circular region with a 6-mile radius, so pretty much the same deal. Instead of a 12-mile radius, we have a 6-mile radius, right? So just a smaller circle. And once again, population density. So it's going to be the number of people, in this case 650,000, divided by the area. And again, because it's a circle, the area of a circle is pi times the radius squared. So pi times 6 squared gets us an area of about 113.1 square miles. So we divide by 113.1 square miles. And we get a population density then of divided by 113.1, and we get approximately 5,747.1 people per square mile. All right, number 5, circular region, okay. Okay, they changed it up on us a little bit this time. Once again, it's a circular region. This time the radius of this circular region is 4 miles. But they change up on us finally on this one because they tell us what the population density is. They say the population density for this region of the city is 6,366 people per square mile. People per square mile. And then what they ask us for is find the number of people who live in the region. Okay, so the idea is that population density is once again going to be equal to the number of people divided by the area. All right? Now, instead of finding the population density, they actually tell us that value. So we can replace population density with 6,366 people per square mile. On the other side of the equation, we do not know what the population in this region is. That's exactly what the question is. But we can calculate the area because it's a circular region, and the area of a circle is pi times the radius squared, so that would be 16 pi. All right, or if you want it as a decimal, about 50.26. So about 50.26 square miles. Okay, so to solve for the population in this region, we have to get rid of division. Let me choose a different color here for the first time today. So we have to get rid of this division by 50.26. So we do the inverse, which is multiplication. So we'll multiply both sides by 50.26 square miles, 50.26 square miles. So on the right-hand side, the 50.26 square miles cancels top and bottom, and we're left with the number of people. On the on the left-hand side, the square miles cancel top and bottom, and the arithmetic is 50.26 times 6,366, which gets us a population of approximately 319,955 people. Okay? So changing up on us a little bit there. Instead of asking for the population density, they asked for the overall population of this area. Okay, number 6 gives us Central Park in New York City is rectangular with a length of 2.5 miles and a width of 0.5 miles. So I'll draw you guys a rectangle just so we have something to work with in our problem. All right, so it's a rectangular area about 2.5 miles in length and about 0.5 miles in width. Sounds good. All right, during an afternoon, its population density is about 15 people per acre. So population density is approximately 15 people per acre. Okay, sounds good. What it asks is find the number of people in the park that afternoon, right? Find the number of people in the park that afternoon. Okay, now the problem is, the challenge for us this time is that they give us the length of the park in miles, the width of the park in miles, but they give us our population density in terms of acres. Okay, so what we need to do is start by finding the area of the park. Once again, it's a rectangle. So we need to find the area of the rectangle first in square miles by taking the length times the width. So that's going to be 2.5 miles multiplied by 0.5 miles, right? So we multiply those together and we'd get the area, 1.25, but it's being measured in square miles. Okay, it's being measured in square miles. Okay, then we have to make the conversion and we have to change 1.25 square miles to acres. All right, and so what we're going to do is we're going to multiply by a fraction that has a value of 1. So this fraction that I'm about to multiply by is going to have a value of 1. So we're not changing the area of the park, we're just going to change the labels or units that it's being measured in. And at the very end of that problem, it says 1 acre equals 1/640th of a square mile. So what we need to do is attach 1 acre to the top, and we need to attach 1/640th square miles to the bottom, because that's what they tell us they're equal to. So what we're able to do then is cancel the square miles with the square miles, and the arithmetic that's left then is 1.25 divided by 1/640th. And so when we do that arithmetic, what we get is that Central Park is approximately 800 acres big. 800 acres big. Okay, and now that we have our area in acres, now we can answer the question, which is, what's the number of people in the park? In other words, what's the population of the park? So just as the previous problem, we're going to use the fact that population density is equal to the number of people divided by the area. Once again, they tell us the population density. Here it's 15 people per acre. We don't know the total number of people, but we know the area is 800 acres. I'm just going to use an A for acres. And then to get rid of the division, just as the previous problem, we're going to have to multiply both sides by 800 acres. So the 800 acres cancels top and bottom on the right side, and then on the left side, the acres cancels top and bottom, and we're left with 800 times 15. So in the park, on this particular day, there would be about 12,000 people. Okay, so obviously a little more of a complicated problem because of the change from square miles to acres. Okay, and I forgot to write down the problem number on that one. I guess I better go back and do that. This was number 6. I'm sure you had that figured out, but that was number 6. Okay, number 7, I'll remember to write it down this time, says about 79,000 people live in a circular region with a population density of 513 people per square mile, and they ask us to find the radius of the region. Sounds good? So once again, in the problem, they tell us it's circular, so I'll just draw you guys a circle so we have something to work with. And then what they tell us is two values about this circular region. They say the total population in this region is about 79,000 people. And they also tell us that the population density in this region is about 513 people per square mile. So people per square mile. And then the question is, what's the radius of the region? Well, because it's a circle, the area of the region is going to be pi times the radius squared. So when we set up our population density formula, population density is going to be equal to the number of people divided by the area. In the problem, they tell us the population density. So they tell us it's 513 people per square mile. They tell us the total population is 79,000 people. And then the area, we don't know what the radius is, but we know the area is pi times the radius squared. And that, of course, would be measured in square miles. So the question is, can you guys then help me solve for R? Well, unfortunately, it's got to be 2 steps. The first step is to get rid of the 79,000 people. I also need to get rid of the pi and the square miles. So what I'm going to do is multiply both sides by pi square miles on top of 79,000 people. On the right-hand side, the 79,000 people cancel top and bottom. The pi square miles cancel top and bottom. And so the only variable left then is r squared, but unfortunately that's in the denominator of the fraction. Okay, on the other side, our square miles are going to cancel top and bottom, and our, I think I have something wrong there because one of those shouldn't disappear. That's per square mile. What did I mess? Oh, here's where I messed up, guys. The radius, we haven't squared it yet, so it should have just been plain old miles, right? So I should still have 1 mile unit left. Sorry about that. Darn it. Get rid of that. So what I need to do is multiply pi times 513, excuse me, and divide by 79,000. So I'll get a pretty small number. I'm going to write it out to a couple of decimal places, 0.0204. And then to solve, excuse me, to solve for r, I need to cross multiply. So multiplying diagonally this way, I'd have 0.0204 r squared. And going this way is just 1 times 1. So to get rid of the weird decimal, divide. So r squared is going to be equal to 1 divided by 0.0204, which is approximately 49. And then to get rid of the power of 2, take the square root. And so r is approximately equal to 7 miles. Okay. All right, number 8 gives us about 1.15 million people live in a circular region with a population density of about 18,075 people per square kilometer. Find the radius of this region. Well, I guess that's exactly the same one that we just did. Well, I could bop through it fast because in case anybody got messed up, I could talk through that one. Once again, what they're looking for is the radius of the circular region. when they tell us that the total population within this region is about 1.15 million. I'm going to write that out. So that would be 1,150,000 people. And the population density is about 18,075. Okay, so once again, our formula, population density, is going to be equal to the total number of people divided by the area. Our population density is 18,075. Our total population is 1,150,000. And the area, excuse me, the area is going to be pi multiplied by the radius squared, but unfortunately, they don't tell us the value for r. So we have to solve for it. So just as we did previously, couple of steps here. First, I'm going to get rid of the pi and the 1,150,000. And whatever I do on one side, I have to do on the other. So on the right side, the pi's cancel top and bottom, the 1.15 millions cancel top and bottom, and so I'm left with an r squared, but again, unfortunately, it's down in the denominator. On the left side, I need to multiply pi times 18,075, and then divide by 1.15 million, and I get approximately 0.0494, just writing it out to a few decimal places. And once again, we solve this by cross multiplying. Dividing by the weird decimal. So divide both sides by 0.0494. I'm just leaving that number on my calculator window because it's just a heck of a lot easier. So when I divide, I get about 20.25. And when I take the square root of that, I get approximately 4.5. So the radius of that circular region, approximately 4.5 miles. Okay? All right. What's up next? I forget. Number 10. Number 10 is the next one there. And number 10, let's see, I haven't read this one. The two islands shown below with the given areas have the same population. All right, so orange and blue have the same population. Which has a greater population density? Well, I hope that's pretty obvious. It's going to be the orange because what's happening is if they have the same population with the orange, we're taking whatever the population is and dividing by 486 square miles. Well, in the blue island, we're taking the population and dividing by 532 square miles. And when we divide by a smaller number, we get a bigger result. So the one with the higher population density is then going to be the orange island. Okay? And then finally, the last one in this assignment is number 13. And what they do there is they change from people to, or animals, to what's called knot density with a K. So knot density. And it says one measure of rug quality is called knot density. Higher quality rugs have a greater knot density. The rug shown and the one they show us here, I'm just going to hand draw this one, is 2 feet by 3 feet. And it says it has, in its creation, 345,600 knots. Okay? So letter A says, find the knot density per square inch. So this is going to be knot density. And so that's going to be the number of knots divided by the area of the rug. Okay, so they tell us the number of knots, 345,600. But the problem says they want the area in terms of square inches. So we have to convert 3 feet would be 36 inches. 2 feet is 24 inches. And so the area then would be in inches, 36 inches times 24 inches. So the rug would have an area of 864 square inches. So 864 square inches. Right? And when we do that division, 345,600 divided by 864, we get 400 knots per square inch. Right? So for letter A, that's the knot density for that first rug. Okay? And then to finish off, letter B gives us a rug that's 3 feet by 4 feet. So again, we'll have to turn that into inches, so that'll be 36 inches by 48 inches, which gives us an area of, 36 times 48 is 1,728 square inches. And then it says that rug has 604,800 knots. Okay, and so to calculate the knot density for the second rug, we take the number of knots, once again that's 604,800, and divide by the area. So we have knots per square inch. And when we do that division, 604,800 divided by 1,728 square inches, we get a knot density of 350 knots per square inch. And the overall question in letter B is that a better rug? And the answer would be no, because the knot density is lower. Okay? Alrighty. So that's all of the problems for section 4. So if you actually followed through and watched this video, you should have the entire assignment then done, right? Shouldn't be any reason not to have it complete when I get back on Monday. Okay? So hope you have a good weekend, and we'll see you in a couple of days.